Okay, so in this section, we're going to talk about how we can use different representations of the same information or the same data. So in this table, you guys are going to see we have an equation, we have a table, and then we have a graph. Okay, and so it's really neat how we can use different, basically like representations, or I'm trying to think of another word. We can take an equation and we can make a table. We can take a table and we can come up with the equation. We can take a table and we can graph it. We can take the equation and graph it. We can take a graph and we can work it backwards. So there's all these connections between these representations, but they're still showing us the same exact thing. So I'm just gonna show you this one. It says the height of an airplane s seconds from takeoff is h equals 12s. Make a table and sketch the graph of the equation. So I've kind of done this one for us. This is our equation. They gave us that. Seconds are positive. We're not going to have negative seconds. So I put in 0, 1, 2, 3. So after 0 seconds, we're still on the ground. But after 1 second, we're already 12 feet in the air. After 2 seconds, we're already 24 feet in the air. And after 3 seconds, we're already 36 feet in the air. So then if we take this info and we graph it, we can give ourselves a visual. So in 1 second, are we gonna even be able, do we have enough numbers here? We're gonna have to change these numbers, and sometimes that has to happen. So I can still use the 1, 2, 3, but I have to change these. Let's go up by 5s maybe? 5, 10, 15, 20, 25, 30, 35, 40. So after 1 second, we were already at 12. So I'm just going to put this just a little bit past the 15. After, this is my 1. This is my 2. 3, 4, 5. After 2 seconds, the plane was already at 24. And after 3 seconds, I was already at 36. And then you guys can kind of see how that line would keep going up and up and up. Okay? So in this section here, it says use tables to generate different representations of data. So I want you guys to take the information off of here and to write an equation. And so one thing that I always ask myself is, what happens to x in order to get y? Okay, so how do I get from 0 to 0? Well, that one might be kind of tough. What about 1 to 6? How would I get from 1 to 6, or 2 to 12, or 3 to 18, or 4 to 24? What happens to the x to get to the y? Let you guys think about that for a second. Couple things that I look at is I focus on one of them. So for example, if I took 1 and I added 5, I would get to 6. But if I take 2 and I add 5, I do not get to 12. So I know it can't be adding 5. The other way to get from 1 to 6 is to multiply by 6. So 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 4 times 6 is 24. So I know that y equals 6 times x. And that works with every single x. Even 0 times 6 gives you 0. Okay, so then if we were to sketch a graph, we can just sketch a graph. I know that these are all positive values, so I can kind of make my positive section larger. I label my axes based off of what numbers I have. So for example, these are just, I have to go 1 through 4. So 1, 2, 3, and 4. But on my y's, I have to go up to 24. So I'm actually going to go by a larger number. So maybe I'd go by 5s. 5, 10, 15, 20, and 25. And then I can go ahead and plot my points. And it doesn't have to be parallel. This is sketching a graph. So if you don't have an actual coordinate grid, you could just sketch the best that you can. So 0 and 0, then 1 and 6, so it's just above that 5, 2 and 12, 3 and 18, and 4 and 24. Obviously, the more accurate you are with, or more consistent you are, you can see my line is actually pretty straight, and that's what our graph would look like. Not perfectly straight, but pretty straight. Okay. So that's how you take a table, get to an equation, and then make a graph. Now it says use a graph to make a table and to write an equation. So again, we have to pick off our ordered pairs to make our table. When x was 0, y was 2. That's the coordinates at this point right here. The next point was 1 and 4. The next point is 2 and 6. And the last point is 3 and 8. So now you guys kind of have to ask yourself, like, how do I get from 1 to 4, or 0 to 2, 1 to 4, 2 to 6, 3 to 8? How is that going to work? Sometimes they are more complicated than others. So for example, I'm going to focus on just one that seems easier. So 1 times 4. So I could do x times 4. And I could do x plus 3. Let's try those. So what's 2 times 4? Does that give you 6? No, it gives you 8. What about 2 plus 3? Nope, that gives you 5. So we're a little bit off here, and we have to try to think of, like, how could we get close? So sometimes you might have to multiply and then add or subtract. So another thing I think about is what happens if I double these and I add 2? Does that work? So like 3 times 2 is 6, plus 2 gives you 8. 2 times 2 is 4, plus 2 gives you 6. And then 1 times 2 is 2, plus 2 gives you 4. So I can kind of scratch this idea, and I have to go back to my other. So if I take my x and I times it by 2, and then I add 2. Let's check. 2 times 0 is 0, plus 2 is 2. 1 times 2 is 2, plus 2. And you can keep on going on. And so we have found an equation that works. So sometimes if I have one that I think you have to do 2 things to it, I will check by multiplying it by a 2 or 3 and see if I can add or subtract to get down to the y that I need. Okay, the last problem, we are going to make a table and graph the path of a submarine driving at 50 feet per minute. The depth of the submarine is represented by the equation. So they give us the equation. We need to just make the table and do the graph. So I'm going to make my table, and instead of an x, I have an m. And my equation, and then my d. Okay. One other thing that I think is helpful, especially in these word problems, is to know what these letters mean. So m is minutes, and d is depth. And they tell us that in the problem, but this helps give an image of what's happening. So if we are doing a real problem and we're putting values in for minutes, are we going to use negatives? No. Do you really want to multiply by decimals or fractions, even though you could with a minute? I don't want to. So I would pick numbers that are nice to multiply. So for example, 0 maybe, and I could do 2, I could do 4 and 6. I just picked some numbers to do. Okay, and then I'm going to put those values in. So negative 50 times 0, negative 50 times 2, negative 50 times 4. Oops, I lost my 0 there. Negative 50 times 6. Obviously, times 0, you get 0. Negative 50 times 2 is negative 100. Negative 50 times 4 is negative 200. And negative 50 times 6 is negative 300. And now we are going to graph. Notice I have positive values for my minutes, but I have negative values for my depth. So I do kind of have to make sure I'm graphing correctly. Minutes is my x. Y is my output. So I could simply go by, 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, 6 minute. And then I need to go down, but I have to go down by pretty large numbers. So you maybe go down by 50s. So for example, 50, 100, 200, 300. And then just notice how I tried to keep my spacing as consistent as I could through there. So 0 and 0, they're at the surface of the water when they started. After 2 minutes though, they were already 100 feet deep. After 4 minutes, they were 200 feet deep. And after 6 minutes, they were 300 feet deep. You can see by this graph that the graph will let us actually make other predictions. It will let us show other values and what's going to keep happening if this submarine keeps descending.